Hello, everyone. Okay, welcome to join Solomon webinar today. I'm Henry Chen, Senior Sales Manager of Solomon Vision. Today, I would like to introduce you our AccuPick SmartPack solution. Together with Luis, he's our Senior Application Engineer. We'll do a live demo for you. I'm going to introduce you the basic function and the company background. So we hope you guys enjoy. And please, if you guys want to receive more information, or you want to test your products, or even you want to just simply keep the webinar record, please scan the barcode in the end. We will provide you all the information. So let's begin. So for the customers who don't know the Solomon company, we are a listed Taiwanese company in start from 1973. And Solomon Group not only provide the machine vision, but we also distribute cobot like you are, or the robot like Kawasaki. And also we are the biggest Rockwell distributor in Taiwan. So we have the well-known knowledge about automation. However, the machine vision department is the standalone department we develop ourselves. We start develop AI 3D vision for more than 5 years. We have the worldwide support business offices in Taiwan, in US, Los Angeles, Detroit, and Southeast Asia, also the China. Also for the next year, we plan to have the European office in either Czech Republic or in the Spain. So we hope the pandemic will close very soon and we will see you guys in person. So of course, today our topic will focus in the logistics material handling applications. We position and we can solve your problem in basically 3 areas. Start from the receiving area. Parcels picking will be our first challenge. Inbound, outbound area, depalletizing will be the second. And order fulfill center, like picking areas, pieces picking, will be the most challenge and also our focus today. So it doesn't matter you have the parcels, soft bag or envelope or rigid boxes. We can all detect it by our 3D vision. Together with AI and robotics, we can provide you really quick, short cycle time and very accurate picking performance. And second, in the depalletizing area, which is labor intense area, we can offer you solve your depalletizing application by 3D vision. In the past, you might need to program your robot according to the box size or the pattern of the pallet. But right now, together with the AI 3D vision, we can accurately recognize the surface and the picking point of the boxes. So we can simulate the boxes on the pallet, not only by any robot programming. We will provide you the single coordinates of the boxes. So in the nowadays, your boxes type become more variable, and also some customer, when they are handling the boxes, the starting position and the ending position might not be the same, which can be solved by the 3D vision. And also for the pieces picking, we can pick from the conveyor or we can pick from the boxes. We have different solutions, but it's really matter is we can using our AI vision to simulate the boxes or the small items, no matter they are round shape, square shape, or irregular shape. The challenge for us, for AI, is to successfully find the center point of those items. And this is gonna be the topic of today. So to give you guys more confident, we are already together with well-known customers in global. For example, in China, we have implemented our system largely in the higher warehouse in China, or the freezer, depalletizing applications, and also in DB Schenker in Singapore. We help them build up 3 lines of bin picking applications. And also in Thailand Tobacco company, we also deploy 5 units of our system in the warehouse line. So We welcome you to also challenge us your applications. We will focus on the technology and the AI to solve your problem. All right. So for the people who didn't know what Solomon can do, we are actually AI 3D platform. We position ourselves as a software company. Our software can connect to your robot and the cobot. We cover more than 20 brands of land, not only sending the coordinates of the picking objects, but also we are able to integrate and control the robots to do the pick and place task. So you no longer need to touch the robot pendant, or for someone who doesn't familiar with the certain system of robot, you can use our software to control and complete your task without any coding efforts. And also, compared to other suppliers, we are more open on the 3D camera integrations. For example, if you focus on the high accuracy or high quality point cloud, you can using our structure light technology Solomon camera or Wingular laser profile scanner, which focus in the manufacturing the most. However, for the logistics applications, time of flight from Microsoft or Intel RealSense are the most desired camera, can provide us the good quality of point cloud and also affordable cost. And also considering the cycle time, both of them are the most ideal camera we will provide and suggest to our customers. So our AI model can be separate into two different models. For logistics, we call unknown model. Basically, you don't have to register what's your objects look like. And according to the AI algorithm, we are able to singulate the items in the bin. And this is the really suitable scenario you use in the logistics warehouse, because you receive different objects every day and you don't know the cat file or the categories of them. But Vision can simply singulate them and to do the pick and place. On the other hand, the non-model for the manufacturing focus on the high accuracy and has to detect the orientation. So the video here, you can see we have the top view and the bottom view, and we have to pick and place them with the right orientation and precision. So different models are all available in the AccuPick 3D. We welcome all the users to try both scenarios. We hope this can help you to also open the market and also to help the end user to really automate their process in the smart factory. Well, speak back to the challenge of pieces picking. Right now, actually, the most challenging part is, so for many different items, different categories of the products, how we can accurately to singulate the boxes or the items. So the AI is the key to do it, to make it successfully. And also with the 3D camera ability, we also need to provide you the accurate coordinates. And some people might be headache for the motion planning. Here, Solomon provides you the collision-free analyzing software to help you not only have the accurate picking coordinates, but also to calculate the collision-free trajectory of the robot path, which will tremendously help you in the bin picking applications. Well, and then some of customer also challenges not only pick and drop, because some of the fragile objects could be damaged. Here, we advancedly provide the customer gently place, or we so-called pack, in their ship out package. So we also decide the third camera to analyze where to place, and even we can measurement your objects during the process. Also, the cycle time is one of the advantage of Solomon. We have some durable testing. We are able to provide you less than 3 seconds cycle time. And the final point is about gripper. In this part, is always the challenge if you want to pick variable things with one single gripper. Later on, I will introduce you how Solomon solve this problem, and by using our vision together with the gripper. So ideally, those target site is already being implemented with some automation warehouse, especially in USA or in Europe. A lot of suppliers offer this kind of automatic warehouse solutions. However, the last milestone is still for pick from the bin to bin, like the human beings, is still the milestone and which Solomon can offer you. So those scenarios are our target site to implement our system. How to make it happen? Together, we have 4 points to introduce you. Start from the AI vision. Second, as I mentioned, vision control grippers and fast dimensioning. And the last point is the user-friendly interface. So you can seamlessly integrate your robot and the scenario to make the pieces picking happen. So of course, internally, we have do largely testing for the reflective surface, black color surface, or you can see densely packed situation is also the challenge we have to solve by AI. However, life is difficult, but the AI can make it easier. You can test with our software by singly rental or buy a single demo unit from us. You can experience amazing of our AI brains. And the second, the gripper part is the challenge. However, here, Solomon provides you the multi-gripper, as you can see here. Our vision can detect the size of the objects by either the long side or the short side, and together to consider the ratio of the dimension. Together with the ratio of the dimension, we will see how many gripper we should reach out. For example, here for the umbrella, we will have 2 grippers. For the large boxes, we can reach out 3 suction cup. So depends on the dimension. The vision will decide how many gripper will reach out to touch the boxes. This is like the module for the I/O control. So you can decide your own gripper. It doesn't necessarily to be only 3, but could be up to your design. The point here is our vision system can decide what's the dimension we are going to pick, and then we will suggest the gripper to focus on the right size of the fingers. And we also test multiple fingers like suction cup or fingers. So you can totally trust and consult with Solomon. We are also the expert of those finger selections. For the dimensioning, one of the biggest customer challenges, they don't want to only pick and drop, but actually they want to know what is the size of the picking objects and how to gently place them into the shipping out boxes. So the concept is we have the 3D camera. One is set up on the picking boxes. Second, we focus on the fast dimensioning. It could be optional if you can offer the system the picking surface 3D. You can offer the object size according to your WMS. So this is optional. And the third camera is to find where to place according to the situation, I mean the locations of the objects inside. So here is the example. Well, you can see after picking, we go to the second camera to do the measurement here. And we will place those boxes gently in the third boxes here. So the third camera will tell the robot where to place and to pack as tight as possible. So you don't have to waste your space in the bin. And also in this way, you can guarantee the customer the product will not be damaged by singly like dropping. So this is the solution we can offer for the pick and place. Some more information top up. So pin collision is one of the biggest challenge, no matter is it in the manufacturing or is it in the logistics. As you can see, those items, they have really challenge picking angles. And if you singly just give the coordinates of those picking objects, you're not going to successfully pick land. Your robot might hit either the beam wall or you hit the cameras. So as you can see, the robot turn around before it picks the objects. It's because the robot sense if they go directly to the picking point without turning, the camera will be hit. So you can see we will have the 3D simulation to calculate what is the right trajectory to pick objects without any hitting. So this is the Solomon collision avoidance solutions. In the next version, we also provide the customer remote control center idea. So ideally, you are able to implement 5 or 10 systems, and one operator or two operator can sit in the control center to remote those systems to see, okay, right now I want to check if the IP, certain IP computer has some problem. We can remote into this computer and see what is going on. Maybe the objects in the corner or some gripper has some issues. And not only just monitoring, but we can define the pick point manually on the objects. So you can adjust the pick point by the adjustment table here. And together with ROS, what we call collision avoidance software, we can solve these error situations by manual operator. So this is the next version functions coming up, and we hope you guys enjoy this. So in conclusion, compare with the Solomon system and manual picking, we believe in the long term, 24 hours, of course, the robot can run still in the same speed stably, up to 900 to 1,000 pieces per hour. And this layout, we are able to control multiple cameras and both Kinect camera on the top and interior sense on the bottom for the placement analysis. And we are able to control more than one station, like compared to human beings, maybe they only focus on single stations. And the error rate, we believe if we integrate with your WMS successfully, all the information and material handling could be 100% monitored and with logics pick and place. So it can avoid some human mistakes as well. So this is the layout we suggest. And right now we are looking for more partners in each region, in each countries. So if you are interested in either manufacturing 3D AI solutions or logistics, please contact to the regional sales. We will discuss with you the package, and we hope to develop a bigger market together. So right now I will introduce you Luis, our engineer, to introduce firstly the red dot design interface, and we will do a short live demo to see the applications. Okay, Luis, it's your turn.
Hello, everyone. My name is Luis. I'm a field application engineer at Solomon, and I'm going to give you a brief introduction of the user interface in AccuPick and our packing solution. Okay. This is AccuPick's user interface, and we call this the flowchart. Here, we can easily drag and drop blocks in order to structure the application that you want to do. We have different blocks for different parts of the system. For example, the capture block is we can set all the parameters related to the vision system. We have one block called the robot script. Here we can connect to the robot, and we can set a robot mission in order to pick or place the objects. We have also a recognition block, which is related to the AI system. Here we can set basically the algorithm to recognize the objects, and we can connect the blocks by the dots. In this way, we can create the flowchart to execute the specific application to meet your requirements. Okay. So let me just give you a preview explanation of the main blocks that we have in our flowchart. I will remove this one for now. The first block I want to show you is the capture block. Okay, here for this demo that we have prepared for you today, we have two Kinect cameras or depth sensors, and we have two bins. The bin on the left, at your left side, will be the one to pick the objects, and the second bin on the right side, we will pack or drop the objects here with the packing application. So in the first block, the capture block, we can connect with the camera, and we can set some vision parameters like the exposure time, the digital gain, the frame rate, or gamma correction. We can also have the robot panel to connect with the robot. We can easily set the IP address of the PC, the IP address of the robot, and some additional parameters like the TCP position, the TCP angle, the payload, and the center of gravity. It's important to mention that we have implemented most of the robot brands in the market, and we have prepared an easy and fast connection that you can use in AccuPick. And we have a calibration panel. In order to do the picking and the dropping with the robot, first we need to perform a calibration. For this process, we use a checkerboard, and we will find a relation between the camera coordinates and the robot coordinates. So all this process can be done in this panel. And finally, we have the 3D panel. Here, we can see the point cloud, basically the 3D information. So I will show you one point cloud now. Okay, so in this case, you can see here the point cloud, which represents the 3D information that we get from the camera. Just a moment. Okay. And here we have some parameters in which we can set up the quality of the scanner. It's somehow is a trade between quality and speed. For example, for this application that is logistics, we can use, let's say, a lower quality, which will make all the application to be faster. But for other applications, if you need, you can increase the quality of the point cloud and you can get more accuracy. Here we also can select a region to pick the objects. In this case, for example, I can set this bin or this one. In this case, we select this bin from where we will pick the objects. Okay, that is an overall view of the capture block. We also have the recognition block. Here we can set the parameters for the AI. So the first thing I want to show you is the region of interest, or we call it ROI. So basically here, from the full image, we can just focus on a specific area from where we will pick the objects. And this will make all the process more efficient. And in the AI panel, we have some tools, like the ones you can see on the screen, depending on the application that we want to perform. In this case, we're using the tool called unknown segmentation. For this one, we don't need to register or teach any products to the software. We just select this tool, and automatically the AccuPick will detect the objects that are in the bin. But we also have, for example, instant segmentation. With this one, you can manually teach to the software the objects that you want to detect. But in this demo, we'll use unknown segmentation. We also have a matching panel in which, in this panel, we will use the detection from the AI panel, and we will transform this detection, which is done in the 2D image, and we will transform it to the 3D point cloud. And we will use this function called plane fitting in order to fit a plane to the 3D information of the object and find the coordinates of the center of this object. And these coordinates will be our pick position for the robot to pick the object there. Then we have additional blocks. For example, the pick drop configuration. Here we can set some parameters for the peak position, like offsets in the XYZ coordinates, some things like that. We also have some filters, 2D and 3D filters based on the detection results from the deep learning and from the plane fitting. And we can basically filter out some objects. We also have the picking priority. We can somehow customize the way that the software selects which objects to pick first. By default, we use the depth, like you can see on the screen. This means that first we will pick the object which is higher in the bin. And finally, in this, the upper side of the flowchart is the one that is related to the picking. Okay, so finally, in this first line of the flowchart, we have the motion plan. For this one, we have implemented our motion planning function in ROS system, and what we will do is we create a virtual scene of our environment, like the one you can see on the screen. With our robot, in this case, we're using a UR10 robot, and we have the two bins, like the ones you can see in yellow. And what we will do is we will generate a free collision path for the robot, the one you can see in the white line. So the robot will follow this path, and what we do is we will generate a path where the robot will not hit the bin. So this is a really important function if you are concerned about the safety in your industrial environment. Okay, so basically that is the overall function of the peak application. And after that, we will send a signal to do the packing application. Okay, so basically in the first block, this is just a wait. We will wait for the previous process to finish, and then we will send the command to the robot script. In our robot script, we can set some missions for the robot. In this case, we have like a P1 start pick and P1 P2, and each one of the missions contains some instructions for the robot to perform the picking. It's important to mention that if you use AccuPick, you don't need to program the robot. You don't need to use any coding. You can just select some robot positions and some functions to control your gripper. In this case, we can turn on and off the suction cap and some weight, something like that. So easily you can set you can easily set a motion for the robot. And we can select in the script the missions that you want to use. So in this case, after we finish recognizing the object and generating the pick point, we will send those coordinates and we will generate a mission for the robot here. And simultaneously, we will trigger the second scanner, and we will try to find an empty space in the second bin in the 3D information. Okay, so at the same time that the robot is doing the picking, we are also calculating the position where we will place the object. And when we are placing the object, we will also trigger the first camera, and we will be calculating the picking position for the next object. So it's a quite efficient process. And in the place block, we will find the let's say the empty space, or we will try to find an empty space, and based on some parameters, based on the object size and based on the size of the container, we will generate a position to place the object. Okay, and finally we will send we have a second robot script in order to perform the packing application. Okay. And the last block is the display. Here, basically, we can show the detection of the result. So the one you can see right now is the detection of the AI or the deep learning. This is the objects that we have detected in our environment. Okay. So this is the overall explanation of our flowchart, and now we will do a live demo for you. Okay. So I will check that all the systems are connected. This is the cameras are connected, and the robot is connected, and motion planning is online. Oh, the last thing I want to mention is, in this case, as my colleague Henry mentioned before, we can use a third camera to measure the object. But for this live demo, we have a function in which we will set the dimensions of the object before doing the picking. So in this case, we're using a box of 150 by 110 and 60 millimeter. Okay. So let me change the size of the first object. Okay, and I will start I will run the system. This is I will for now I will disable the 3D display to make the process faster, and I will show you the live camera. Okay, and here we go. You can say we can speed up. So as you can see in this on the screen, we are picking the object, and then we will move to the second bin to drop the object with the packing application. Right now, we are not using the maximum speed for the robot because it's a live demo, but we can speed up the process. It depends also on the robot brand. Okay, so now my colleague will input more objects in the bin with a different size. And I will set the new dimensions for this object. Okay. Now, as you can see on the screen, we have now some other type of object with a different size, and we can continue with the process. Okay, and we will try with a third object with a different size. I will input the size of this object. Okay, and we can continue with the process. Switch the camera. Switch the camera view so that I can see. So the detection rate. So as you can see in the bin in the right here, we have the detection from deep learning, and in the second bin at the left on the screen, we have the packing application.
show the second camera result.
Let me move the robot. So let me show you the result of the here. So right now on the screen, you can see the result of our packing application. And we have used 3 different objects with different size. And for this case, we didn't use the measure, but it's also possible if you have different objects in your bin that that maybe you don't have a register of the size. We can connect, or we can set up a third camera to measure the object before going for the packing. Okay.
Okay, Luis, please sit back. So thank you, Luis, for such a detailed introduce. If you have more questions, please you can anytime write an inquiry to us. No matter you from which country, we have the corresponding sales for your questions. And again, we are looking for more projects and challenges. Please welcome to contact us, and we will send you the video and the information. So we will see you soon. Bye bye.
Bye bye. Thank you for attending.